Hey everybody, we are going to be going over how to draw Lewis structures that have multiple bonds in this video, and we're going to be talking about how to draw Lewis structures that have multiple centers because you're going to kind of see that as we get more practice with these. So the first example that I want to go over is H2CO3, and like Mr. Hall said in the previous video, we need to first figure out how many valence electrons we're going to be able to bring to the party in our Lewis structure. So our hydrogen here has one valence electron, and there are two of them in our formula. So that is going to have two electrons coming from the hydrogens. Carbon has four valence electrons, and there's only one of those. And then oxygen brings 6 electrons, and there's only one of those. So when we take a look at our grand total of electrons, we're going to have 12 electrons in our picture. Now remember, you cannot put any more electrons in the picture than the valence electrons allow. So I can't have more than 12 electrons, and I can't have less than 12 electrons in my picture. When I draw this Lewis structure, I have to pick my central atom, and like Mr. Hall had said, hydrogens can only make one bond, so hydrogens are bad central atoms. A lot of times your center atom is written first in your formula, but not in this case. In this case, we're going to take a look at the next one, which is the carbon. And carbon can make 4 bonds in theory because it has 4 unshared electrons in its original kind of Lewis structure with just one carbon, so we're going to pick that. So like I said, most of the time the hydrogen or the first element that is in your formula is going to be your center, but not in this case. So I'm going to put a C, and then I'm just going to connect it to the other elements that are in here. So the O and the H. When I did that, I drew in 6 electrons effectively. So if you think about each bond as 2 electrons that I drew in 3 bonds, so I'm going to take away 6 electrons from my picture. And that means that I have 6 electrons left to distribute to make my octet rule work. Like Mr. Hall said, we're going to start with the outside elements first and then work our way into the center of our atom. So if we start with these hydrogens here, each of the hydrogens already can count 2 electrons towards its count, and hydrogens follow what we call the duet rule, where they only need to have 2 electrons because they're so tiny. So this hydrogen and this hydrogen are good because we have 2 electrons in the picture for them. So we're going to go to oxygen next. And if I cover up everything here, oxygen has 6 electrons. I'm sorry, not 6 electrons. It has 2 electrons around it in our picture, which means that it's going to need 6 more electrons to fill out the octet rule. So I'm going to put those in and be done. However, if we take a look at carbon and we cover up kind of everything that's in there, carbon has 6 electrons in its current Lewis structure, but I just took the 6 electrons that I had left in my picture and I put them around oxygen. So carbon is going to be 2 electrons short. And what we do in situations where we are short electrons is we have to kind of reclaim them from the elements that we filled the octet for and bring them into the center. And so that is how you're going to get a double bond or a triple bond forming, is that we're going to recollect these electrons and bring them to share. Now, in the case of carbon, carbon is only short 1 pair of electrons. So what I'm going to do is I'm going to drag the electrons from the oxygen down and share them. This is going to require you to redraw this Lewis structure. So I would definitely use pencil or be committed to redrawing. And what I do to show a double bond is I draw a second line there. So what I did was, instead of having the electrons as an unshared pair on the oxygen, I brought them down here, and now they're a shared pair, and it looks kind of like that. So that is how we do a double bond. And if you would be short 2 bonds, then you would bring in a second pair and you could make a triple bond. Okay, so what I'm going to do is I am going to do another example, and then I'm going to have you pause the video and then we'll walk through it. So the compound that I would like you to draw is, I would like you to draw N2. So pause your video, give this one a try, and then come back and see if you got it right. Okay. If I find nitrogen on my periodic table here, nitrogen has 5 electrons in its valence shell, and there are 2 of them in this formula. So that means my electron count is going to be 10. I can't put less than 10 electrons, and I can't put more than 10 electrons. And since it's just N2, I'm going to have an N and an N side by side next to each other. We start off everything assuming that the single bonds are going to work. So I'm going to draw one line connecting the nitrogen and the nitrogen, and that represents 2 electrons that I've put in my picture. So I have 8 electrons left to add. It's up to you if you're a left person or a right person to start adding them. I usually start on the left side of the molecule, and so I'm going to start adding 8 electrons to my picture. If I look, nitrogen here has 2 electrons connected to it already, so it's going to need 6 more. 1, 2, 3, 4, 5, 6. Okay, and now this nitrogen on the right hand side also needs 6 electrons, so I'm going to add that pair in. But the problem is that I need 4 more electrons to complete the octet for nitrogen. And you can't just like write them in. You can't be like, oh, I guess I'm writing that in and that's what's happening. No, you're limited to those 10 electrons. So what you have to do is you have to take those electrons from the nitrogen that has a satisfied octet, and you're going to bring in a pair here. And since I am 4 electrons short, I have to bring in another pair from the nitrogen that's already satisfied. Those become triple bonds. So what I'll do is I'll draw my nitrogens again, and now I'll have 3 pairs of electrons that are shared between them. And if we want to redo our math, we can do that. We'll have 10 electrons minus now 6 electrons because we have 3 pairs in there, which means I have 4 electrons left for my Lewis structure. Okay. Then I'm going to distribute those. So my nitrogen here now has 6 electrons in its picture, and it wants 8 so that it can satisfy the octet rule. I'm going to have 2 pairs or 2 electrons here in a pair, and then the same thing for the other nitrogen. I'm going to also have 2 electrons on the end, and that counts as 8. So in this case, I'm going to need a triple bond to make that happen. Okay? So one other thing I want you guys to be aware of is that sometimes you are going to encounter compounds that have kind of larger chemical formulas, like C2H6. So C2H6, we'll do our electron count for that particular element. Carbon brings 4 to the table, and there are 2 of them, and each hydrogen brings 1 because it's in that first column, and there are 6 of them. So if I do my addition, I have 8 here and I have 6 here, which leaves me with 14 electrons to put in my Lewis structure. So if I would start this out and I would do C2H6, okay, if I look at this, I do C2 and then an H and an H and an H. The maximum number of bonds that you can put around a carbon, and in our case, any element that we're talking about, is going to be 4. So you can't put more than 4 bonds on any one atom that we're talking about. So what we have to do now is we have to kind of branch out our molecule. So we've got 3 hydrogens here. I need to put 3 more hydrogens in another place, and hydrogens will not allow branching. So this is not a legal move here. So the only other element that can take those hydrogens are going to be this carbon next door. Okay, so I've got to put them somewhere, and this carbon seems like a good candidate to do that. I'm going to go through and I'm going to check my electron count to see how that went. So I put in 1, 2, 3, 4, 5, 6, 7 bonds. So that counts as 7 electrons. Or I'm sorry, counts as 14 electrons. So here's hoping our octet rule is all good to go. If I check this out, I've got each hydrogen connected, so that follows the duet rule. This carbon has 4 bonds, so it has 8. This carbon has 4 bonds, so it has 8, and its octet rule is good to go. So this is the correct Lewis structure. So what happens is, a lot of times when you see a double element first. So if you see a 2 here, that usually means that you're going to have almost like 2 different centers on your atom. This would be center 1 and this would be center 2 here. So I've got kind of 2 central atoms going on. So if you would see something like N2H4, any kind of formula like that, when I see 2 of these, usually it gives me the hint that I'm going to have a double center on my atom here, and then I'll branch out. Typically, I try to branch things out as equally as possible. It doesn't always happen. You will also see chemical formulas sometimes. So, for instance, C2H6, you may see written as CH3CH3. And you look at that and you're like, I have no idea what that is telling me. Sometimes chemical formulas, especially in carbon-based compounds, those are going to be written to give you hints about the structure. So when I say CH3 and then I see another CH3, that makes me think in my head that my compound might have one segment that's a CH3 and then another one that's another CH3. And if you look at this part here, a C with 3 H's is what they're talking about. And then this is a C with 3 H's. Another example of that might be something like this. CH3, CH2, CH3. So when I look at that, the Lewis structure is CH3, CH2, and then another CH3. So sometimes the structures, they're kind of given hints about how they write their chemical formula, okay? You could also see this compound written as C3H8, and then when I'm drawing my Lewis structure, the 3 here lets me know that I probably have a 3 carbon center, because it's carbon and carbon and carbon, and then I'm going to work to distribute my hydrogens around the side. So you're going to be doing some practice with these. Please make sure that you give them a try. The only way you're going to get better at these is by doing practice, practice, practice. So give them a try, and if you find that you're having questions, come to a meet, and then we will answer all of your questions. Good luck.